Hello everyone, welcome to Biswadeb classes. তো এটা আমাদের না লাস্ট ভিডিও আমাদের যে PYQ সলিউশন সিরিজের লাস্ট ভিডিও। এটা হয়ে গেলে আমাদের পুরো পেপার কমপ্লিট। ইচ এন্ড এভরি কোশ্চেন আমরা ডিটেইলসে ডিসকাস করলাম। আই হোপ তোমাদের সমস্ত ডাউট ক্লিয়ার হয়েছে। এরপরে আমি আর লাস্ট একটা ভিডিও আমি প্রিপেয়ার করব। সেখানে না আমি তোমাদের কমেন্ট বক্স থেকে দেখবো কার কি কমেন্ট আছে, কি ডাউট আছে, নট অনলি কমেন্ট, তাদের কি ডাউট আছে আমার পুরো এই সলিউশন সিরিজের আন্ডারে। তো আমার নেক্সট ভিডিওতে না আমি তোমাদের সেই ডাউট গুলোর উপরে একটা ভিডিও বানাবো। আমি কমেন্ট বক্স থেকে দেখবো কার কি ডাউট আছে, কি কি কমেন্ট করেছো, সেখানে তার কার কি ডাউট হয়েছে কোন কোশ্চেনের উপরে, তার উপর আমি ভিডিও বানাতে চলেছি। তো যাই হোক, এটা আমাদের আজকে লাস্ট পার্ট আমাদের সলিউশন সিরিজের গ্রুপ সি EFG। Okay, after solving these three questions, my entire problem set with solution of each and every question is done. Okay, so let's start solution. So my first question of this series is you have to find out the dimension and the basis of the solution space of the system. We know what is basis. Basis means those vectors which are linearly independent and they must generate the entire space. Okay, independent basis means they should be independent, thus they should generate or they should span. Span means what? Span means we can express it a linear combination. For example, suppose my vectors are like this. It can be written like this. We know this very well from our vector concept. Okay, so see that these vectors can be expressed as a linear combination of these three, right? These three vectors can be expressed as a linear combination of these three. That means these three vectors span x1, x2, x3. So it's the concept of spanning vectors. Moreover, we know these three vectors are independent. Why? If you form a determinant with the help of them, you can see that my determinant is non-zero. So these three vectors are independent, as well as these three vectors span entire space. This is called by RQ. This is called by RQ. So these three vectors form a basis. This is my concept of basis. Okay. So you can go through any standard book to understand this concept of this basis. So how you can solve this question? Again, see that we shall again find out our echelon structure, echelon form. See that from this we can form a matrix. My coefficient of x is 1, coefficient of y is -2, coefficient of z is 1, coefficient of x is 1, coefficient of y is -2, coefficient of z is -1. So see that with the help of these two, we can form a matrix like this. Now we shall find out its echelon transformation. We know echelon transformation very well. So my first row, what is my echelon transformation? This is my 1, this element is 1, and we know that the element below it should be 0. That means this element must be 0. So we are using the operation R2 minus R1, giving you 1 minus 1 is 0. -2 minus of -2, -2 plus 2 is 0. And then -1, there is my -1, R2 minus R1. This is my R2, there is my R1. R2 minus R1, there is my -2. See that this is my echelon structure. And we know how to form echelon structure. I've solved so many questions in this PYQ series. Okay, like this. So I hope you guys have understood this type of echelon transformation. So we form another matrix, and this is called my echelon matrix. And see that all these rows of this matrix are non-zero. Okay, all these rows of this matrix are non-zero, and hence we can say that this matrix are rank 2. This matrix are rank 2. So see that to find out basis, we need independent solution. Okay, independent solution. So how to do that? Okay, so this matrix reduces into this form. Okay, so we get another system of equation. After this echelon transformation, we get another system of equations like this. Say say this matrix is 1, minus 2, 1. See that? We get another structure. Then here is my x, y, z, and it is 0, 0. Basically, this matrix and this matrix are equivalent matrices. Okay, these two matrices are basically equivalent matrices. Equivalent. So from this, we are getting two equations: 1 into x minus 2 into y plus 1 into z is equal to 0. 0 into x, 0 into y, and minus 2z is equal to 0. So from this, we are getting two equations like this. Okay. So now we have to find out number of independent solutions from this. So how to do that? Say that from the last equation, we are getting, from my last equation is minus 2z equal to 0. From this, we are getting z is equal to 0. So my choice of z is always 0. Okay. My choice of z is always 0. And if we put z is equal to 0 here, this will be x minus 2y is equal to 0 because my z is 0. And from this, we are getting x equal to 2y. X equal to 2y. Or you can write y equal to x by 2, whatever your desire. Okay. So x equal to 2y or y equal to x by 2. So whatever you want, you can do this. Either you can write x equal to y or y equal to x by 2. Okay. So see that my solutions are, so my solution vector. What is my solution vector? My solution vector is my value of x is 2y, my value of y is y, and my value of z is 0. Okay, see that. My value of x is 2y, my value of y remain y, and my value of z is 0. So this is my independent solution. See that. This is my only here. Okay, independent solution. But y is what? But y is any real number. Okay, it's a very easy question. This is my independent solution, and this independent solution span this space. Okay, this is because this is my echelon transformation. Echelon transformation means what? These two vectors are independent vectors. Okay, these two vectors are independent vectors. That means these two vectors, okay, these are my equivalent structure of this echelon form. We are getting two vectors, and after solving this system of equation, we are getting my structure of solution vector is this. Okay, my structure of solution vector 2y, y0. So this is my independent solution, and this independent solution will span this system. Okay. For example, if you put y equal to anything, say x, okay. So if we put y equal to 1, my solution will be 2, 1, 6. If we put y equal to 1, my solution will be 2, 1, 0. That means this vector will span this space, this system. Okay. So for different values of y, you shall get different solution. That means this solution is infinite. There are infinite number of solutions. If you put y equal to half, there will be another solution. If you put y equal to minus 1, there will be another solution. And all these solutions span this space. Right? So this is my independent solution, and this solution will span this. That means we can say that this solution form a basis. This solution form a basis. Okay, right? And last part, you have to find out its dimension. How to find its dimension? What is the meaning of dimension? Dimension means number of independent vectors in the basis. Number of independent vectors in the basis, it is called dimension. Now here you can see that there is only one vector. In the structure of the vector, there is a structure of the vector for different values of y, you shall get different vectors. For example, if we put y equal to 1, this is my vector. You can see that there is only one vector in this solution space. Okay? And okay, whatever be the value of y, there will be only one vector. And since there is only one vector in the basis, my dimension of will be 1. My dimension of the solution space will be 1. Okay, the solution of this question. Okay. So if you have any problem, you can ask the comment box. My next question, transport this system. So very easy question. We have solved this so many questions like this in our class 11, 12 course. This is a system. You have to reduce this system in the form AX equal to B. How to do that? This is my system. This is my system. Now, the system can be written as my coefficient of x is 2, my coefficient of y is -3, my coefficient of z is 4, my coefficient of this 3, it is my 2, it is my -1, it is my 5, it is my 3, it is my -1. Then x, y, z, then 3, 4, 7. Okay, so let this equation, this is A. This is A, there is capital X, and this is capital B. Same. So my AX okay equal to B system. Done. This part is done. AX equal to B. Now hence solve it by property of matrix. Now see that there are so many methods of solving this system. Echelon transformation method that we have done previously. Echelon transformation method. But if we apply the property of matrix, there's an interesting property of matrix. So we know if AX equal to B, okay, if AX equal to B, we can write X equal to A inverse B. If AX equal to B, my X equal to A inverse B. This is an important property of matrix. Provided this matrix is invertible, my capital A matrix is invertible, and capital A is invertible when my determinant of A will be not equal to 0. Determinant of A is not equal to 0. This is my property of the matrix. Okay, and since a solution exists, we can assume that determinant of A is not equal to 0. Otherwise, you can't solve this system. So assuming determinant of A not equal to 0, we can assume A inverse exists. So find out A inverse. You can easily do this. Okay. And if you forgot how to find inverse, just ask me in comment box. I shall make a video on inverse of matrix, how to find inverse of a matrix. Okay, but I think you know how to find inverse of a matrix very well. So my X equal to A inverse B. So just find out inverse of this matrix and multiply it with B. 3, 4, 7. You shall get value of X, value of Y, value of Z. So find out inverse and multiply it with 3, 4, 7. You shall get 3 numbers like this. And these are your X, Y, Z. Say this is X1, Y1, Z1. Okay. So you can easily do this. Okay. So যদি inverse নেই ওর কোনো doubt থাকে comment box এ ask করবে. Okay, ask me in comment box. I will definitely make a video on inverse of the matrix. So it's an easy question. A, after finding A inverse, multiply it with B. You shall get your X value, your Y value, your Z value. Okay. This is basically a calculation. I'm not showing you this calculation because you will feel bored. So, calculate করলে না তোমার bored feel হবে. Coming to the last question. This is my last question of this entire PYQ series. Problem number 6G. So in this question, we have to find out linearly independent subset. We have to find out linearly independent subset of this set out of these 4 vectors. We are given 4 vectors. Out of these 4 vectors, we have to find out linearly independent subset that span this space as S. Okay? How to do that? For this, we shall use the result from very basic result and standard result. The result is in R to the power n. there are maximum n linearly independent vectors. In R to the power n, there are maximum n linearly independent vectors. Or we can also say that in R to the power n, there cannot be more than n linearly independent vectors. And if it is R to the power n, there cannot be more than n linearly independent vectors. Maximum n of it. For example, this is my R cube. Why is R cube? There are 3 components. So this is my R cube. So in R cube, maximum 3 linearly independent vectors can be there. Okay. In R cube, there can be maximum 3 linearly independent vectors. But here we are given 4 vectors. So these 4 vectors cannot be independent according to this result. Okay. So we have to. So there can be maximum 3 linearly independent vectors, or it can be 2, and so on. Okay, but cannot be 4 because it is R cube. So for this, we shall use another important definition. It's a very basic definition. This is called pivotal element. What is pivotal element? It is the first non-zero element. It is the first non-zero element in each row of a matrix in its echelon form. So what is called pivotal element? This is my first non-zero element in each row of the matrix in its echelon form. I shall explain you with the help of this example. Okay. So this is okay. This is my result and this is my pivotal element. So using these 2 concepts, I shall use this. Okay, I shall solve this question. So here my vectors are this, and this. Okay. So with the help of these vectors, we shall form a matrix. We shall form a matrix capital A. My first vector is 1, 2, 1. My second vector is -3, -6, 3. My third vector is 2, 1, 3. And my fourth vector is 8, 7, 7. These are my vectors. So I shall find echelon form of it. Okay. I shall find echelon form. This is my first non-zero element, and it is already 1. So this element will remain as it is. Then, according to echelon form, make this element, reduce this element to 0. My operation will be R2 minus 2R1. R2 minus 2R1, 2 minus 2 into 1 is 0. Okay, 2 minus 2 into 1 is 0. Then my R2 is -6. -6 minus 2 into -3. It is -6 plus 6. It is 0. My next element 1. My next element is 1 minus 2 into 2. So 1 minus 4 giving you -3. And this is my 7 minus 2 into 8. 7 minus 16 giving you -9. Echelon form, just a basic calculation. Then this element has to be 0. For this, we are using the operation R3 minus R1. 1 minus 1 giving you 0. It is my 3 minus -3. It is 3 plus 3 giving you 6. Then 3 minus 2 giving you 1. R3 minus R1. Then R3 minus R1, 7 minus 8 giving you -1. Okay. Just take the calculation. R3 minus R1, 3 minus 2, it is 1. Then 7 minus 8 is -1. Right. So this is my echelon structure. We are forming the echelon structure. Then what? Then from this, I can also okay, so this is my echelon structure. Now see that this element is 0. For this, we are interchanging between R2 and R3. We are interchanging between R2 and R3. So If we interchange between them, this will be 0, 6, 1 minus 1, and this will be 0, 0, minus 3, minus 9. We are interchanging between R2 and R3 like this. Okay, so my R2 comes here, my R2 comes here, my R3 comes here. Okay. Then what? By echelon form, we know we have to reduce this element to 1. So my formula will be my operation will be R2 into 1 by 6. R2 into 1 by 6, 0 into 1 by 6 is 0, 6 into 1 by 6 is 1. It is 1 into 1 by 6. It is minus of 1 by 6. And 0, 0, minus 3, minus 9 remain as it is. Okay. And see that this element is already 0. This element is already. Then what? Then we know by pivotal method, this element has to be 1. But it is okay if you keep this element as it is. Okay. If you keep this element as it is, you shall get same answer. But still, if you want to make this element to 1, what is my target? My target is to reduce first non-zero element to 1. First non-zero element take 1 korte hobe. That is my target. Okay. So first non-zero element jodi 1 hoye jay, my target is complete. So, okay, so this is my first non-zero element, it is 1. First non-zero element, it is 1. So reduce first non-zero element to 1. We shall use the operation R2 into minus 1/3. করলে কি হবে রাখো, করলে এটা আসছে এরকম। ওকে, সো 0 into minus 1/3 0, 0 into minus 1/3 0, এটাকে করলে 1, এটা এটা করলে এটা 3 হয়ে যাচ্ছে 1. So this is my complete echelon form. Okay, see that. So this is my pivot element, first non-zero element. This is my first non-zero, this is my first non-zero. So see that if you keep this element minus 3, you shall get same answer. So this is my echelon form and these are my pivotal element. So by theory, we know that this is my first pivot column. This is my first pivot column. This is my second pivot element. So this is my second pivot column. This is my third pivotal element. This is my third pivot column. So these are my pivot column. First, second, third. Okay, and corresponding vectors are what? See that corresponding to first pivot column, my vector is alpha 1. Corresponding to second pivot column, my vector is alpha 2. Corresponding to third pivot column, my vector is alpha 3. Okay. So my independent vectors are alpha 1, alpha 2, alpha 3. So these are my independent vectors. See that. Okay, because this is my first pivot element, this is my second pivot element, this is my third pivot element. Corresponding, so this is my third pivot column, the second pivot column, my first pivot column. Corresponding vectors are alpha 1, alpha 2, alpha 3. Okay, see that. So we have to always find out first non-zero element in each group. So this is my answer of this question. Okay, and one more thing is, as you can also check whether alpha 1, alpha 2, alpha 3 are independent or not. For this, form a determinant by using alpha 1, alpha 2, and alpha 3. Alpha 1 is 1 to 1. Alpha 2 is minus 3, minus 6 and 3. And alpha 3 is 1, 3. You can form a determinant and you can check whether this determinant is non-zero or not. Definitely you shall get non-zero determinant. Definitely you can check it. You can check it, this determinant will be non-zero. Okay. So always find out first non-zero element or my pivot element. Actually, this question would be quite interesting if we take this element as -3. In that case, this problem will be quite interesting. In that case, you can see that my pivot column will be first, third, and fourth. Second one cannot be my pivot column. Okay, you can check this. First, third, and fourth. These three will be my pivot column in that case. But unfortunately, it is 3 is given. It is given as 3. So my vectors are alpha 1, alpha 2, alpha 3. You can check this determinant. You know how to find determinant. 1 into -18 -3, and then 3 into 6 minus see that 3 into 6 minus 1, and 2 into 6 plus 6. Okay, clearly it is a non-zero number because after calculation it is by -21, 5, 15, and 24. Clearly it cannot be. I can check this calculation. I'm not interested in this calculation because we know it will be non-zero. Okay, see that. So this is my answer to this question. My independent vectors are alpha 1, alpha 2, alpha 3. So my okay, all the questions from PYQ series is done. Okay, if you have any problem, any doubt from this PYQ series, don't hesitate to ask me in comment box. My last video. Okay, I shall make another video. I shall prepare another video where I shall clear all doubts from comment box. Okay, যারা যা কমেন্ট করবে না তাদের সমস্ত কমেন্ট থেকে আমি কমেন্ট গুলোকে নিয়ে একটা ডাউট সলভ করাবো। ওকে, that will be my last video, so don't hesitate to comment. The comment in the full video. PYQ series the last part ওটা বলতে পারো। ঠিক আছে, actually my PYQ series end here, but for your doubt I shall make another video. Okay, so till then, bye bye.